Okay, welcome back everyone to Grockit's OGTV. This is the GMAT edition. We are going through the official guide to the test, 12th edition of the book put out by the makers of the test. This is Grockit, and my name's Jim Jacobson. That's me up in the corner there. You can't see it, but I'm smiling at you. And welcome. Last time we left off with question number 148 on page 173 in the book, and so now we're going to pick up with 149, the second column on page 173. We're a little over halfway through the problem-solving questions in this section. So let's get this up and running here. So page 173, question number 149. Answer choices, getting them on the board. 180 minus x over 2, x plus 60 over 4, 300 minus x over 5. Some very different looking answer choices. So it looks like there's room for computational and conceptual errors in this particular question. And then 12,000 over x plus 200. Okay, so during a trip, Francine traveled X% of the total distance at an average speed of 40 miles per hour, and the rest of the distance at an average speed of 60 miles per hour. In terms of x, what was Francine's average speed for the entire trip? A couple formulas that we need to know here. It is a distance or a rate question, if you want to think of it that way. Two key things are that distance equals rate times time. And then, of course, if you're solving for rate or time, you can divide or multiply the other sides as appropriate. Well, the other thing that we need to know is average speed. Average speed equals total distance over total time. Okay, so a great place to start is setting up a chart. We have Francine's distance equals her rate times her time. Okay, and so for simplicity's sake, since we're dealing with percentages of a distance, let's say that she actually traveled, 100 miles. So that x% of that 100 miles will be, the percent will be the number of miles. That makes our life a lot easier. So for the part where she was going 40 miles an hour, she traveled x%, which is the same thing as x distance. And in this case, we could also say t equals d divided by r, because time is the thing that we don't actually have a value for right now. We derive that formula this way. Probably should make it lowercase. Okay, so distance divided by rate is time. So in this case, her time was x over 40. For the second part of the trip, we decided that she did 100 miles total. So her distance for the second part is 100 minus however long that first percentage was. That was done at a rate of 60 miles per hour. And the time is going to work the same way, where the distance is the numerator, 100 minus x, and our rate is the denominator. So that's pretty good. So from this, we can actually sort of figure out her total time. We can add together x over 40 plus 100 minus x over 60, because those are the two time values for the two parts of her trip. So x 40ths plus 100 minus x over 60. And of course we need a common denominator. 40 and 60, the common multiple is probably going to be the least common multiple, or the easiest common multiple, which isn't a mathematical term, but it's going to be 120. So we need to multiply this guy times 3 and we need to multiply this guy times 2 to get them in the correct format. So this is the same thing as 3x over 120 plus 200 minus 2x over 120. We can add them together. 3x minus 2x equals x. So we end up with x plus 200 over 120 is her total time. And of course, that's not what the problem is actually asking for. The problem was asking for her average speed, which is total distance over total time. We do know her total distance as well, though. So we have the total distance. Remember, we just decided, because we're deciders, we decided that that would be 100. So total distance is 100 over total time, which is itself a fraction. X plus 200 over 120. We would multiply our numerator and our denominator by the same thing to get rid of that fraction in the denominator. We end up with 12,000 over x plus 200, which looks an awful lot like what answer choice E has. So there we have it, answer choice E to question number 149. So 173, question 150. We have negative 3/2, negative 1/2, 0, 1/2, and 3/2. So because of the similarity of the answer choices, we're looking at perhaps a minor computational error, and then a conceptual one that clearly has to do with whatever sign we're doing. Again, without even looking at the problem, you can tell some things by looking at the answer choices. So if x equals -1, then the quantity x to the 4th minus x cubed plus x squared all over the, x minus 1 equals something. So x equals -1. The thing to remember about raising negative numbers to exponents is that every even exponent, it's going to be positive because it gives you even numbers of negatives times negatives. Remember, you multiply a negative times a negative, you get a positive. Every 2 times you do that, it's going to switch the number back to a positive outcome. And since it's 1, really each of these answer choices are going to alternate between 1 and -1. So x to the 4th, I'll rewrite this in here, x to the 4th minus x cubed plus x squared all over x minus 1. So we have 4 different powers of -1. The even numbered ones will be positive ones, the odd numbered ones will be negative because x itself is negative. Let's fill in the blanks. X to the 4th is 1, it's an even one. X to the 3rd is -1. X squared is going to be a positive 1. And then x itself is, of course, -1. So then we just solve it. So 1 minus -1 is the same thing as 1 plus 1, and then that last one stays a plus 1. -1 minus 1 makes it -2, so we have -3/2. Answer choice A. And from that we can move on. Okay, so 173, 151, okay. Come on, there we go. Okay. So a toy store regularly sells all stock at a discount of 20% to 40%. If an additional 25% were deducted from the discount price during a special sale, what would be the lowest possible price of a toy costing $16 before any discount? So it starts out at $16. We know that it's going to get 20 to 40% off just by default, and then an additional 25% discount. And we're looking for the lowest possible price on the toy, which means the largest possible discount. So we need to have a 40% discount and a 25% discount, which is the same thing as multiplying the price times 0.6 and 0.75. Because remember, the actual price then is the reciprocal of the discount. You could figure it out where you actually figure out what 40% of 16 is and then subtract it from 16, or you can just multiply it times 0.6, whichever one makes more sense to you as long as it doesn't make you take too much time. Also note that with these percentages, it actually doesn't matter what order we do them in because they're both discounts on the original price. So in this particular case, it's actually a little bit easier to figure out what 3/4 of 16 is because it's divisible by 4. So so basically 16 times 0.75 times 0.6. Save you a little bit of trouble with the math. It all ends up equaling 720. I trust you guys to do that math on your own. And it is that simple. It's just we need to make sure that we understood that we need the largest possible discount. I'm actually wondering, yeah, right there. 880, of course, is the amount that is taken off. So this one's a trap. The remaining price is. I probably shouldn't have put a square around that one, but the big word trap there indicates that. Anyway, 720, choice B, is the correct answer. We turn the page at last to page 174. Question 152. So we have square root of 13, 2 times the square root of 13. 6, 8, and 10. The shaded portion of the rectangular lot shown above represents a flower bed. If the area of the bed is 24 square yards and x equals y plus 2, then z equals what? So I'm going to draw a little diagram just so that you don't have to take your eyes off the screen. X, Y, Z. These are flowers. Additional drawings like this, of course, are unnecessary on the real GMAT. Okay. We also know then the area of the bed, which is the shaded portion. So the area of this triangle, which is a right triangle, is 24. Area equals 24. And we know that x equals y plus 2. So the area of this triangle, another formula that you definitely need to know for the GMAT, the area of a triangle, I'll just write it out. The area of a triangle is 1/2 the base times the height. And we have both of those numbers, or at least that we have them relative to each other. So we have the area. So the area, 24, equals 1/2 of x times y. And we also know what the value of x is in terms of y. So 24 equals 1/2 of y plus 2 times y. Multiply both sides by 2, we get 48. And we get y squared plus 2y. we get all of the things all on one side of the equation. We get y squared plus 2y minus 48 equals 0. And to factor out, to do reverse FOIL on y squared plus 2y minus 48, we have two numbers that multiplied together give us negative 48 and added together give us positive 2. In this case, it's going to be y plus 8 and y minus 6 equals 0. So y equals negative 8 or 6. Since we're dealing with an actual flower bed, see, I drew the flowers and everything, we can't use negative distances. There are no negative distances in real-life flower beds, only positive ones. So y equals 6. We also then know that x equals y plus 2, x equals 8. Then we can solve for z. Do note, of course, our trap answers here. This is the value of y right here. This is the value of x. So if you weren't following along carefully, you might have chosen those. You know, you stop a little bit early when you realize you've solved for something. It just happens to be what the question isn't asking for. We use the Pythagorean theorem. X squared plus y squared is going to equal z squared. So x was 8, so 8 squared plus 6 squared equals z squared. 64 plus 36. 64 plus 36 is 100. I'm going to draw this line in here so that it's clear. So 100 equals z squared, so z is going to equal 10. Answer choice E. You also could have recognized from the two sides of the triangle being 6 and 8 that this is what's called a 3-4-5 triangle without even doing the Pythagorean theorem. These are what are called Pythagorean triplets. If one side is a multiple of 3 and another side is a multiple of 4, and you're left with the third side of the right triangle, the third side is going to be the same multiple of 5. So 2 times 3, 2 times 4, and 2 times 5. Pythagorean triplets are your buddies on the GMAT. It saves you a little bit of time. Okay, answer choice E. That's 152. So page 174, number 153. So we have 9, 19, 21, 23, and 33. Okay, so Jack is now 14 years older than Bill. If in 10 years Jack will be twice as old as Bill, how old will Jack be in 5 years? So we have a couple different equations that we can do here. We have we know Jack is 14 years older than Bill, so J equals B plus 14. If we want to put it the other way, we would just do B equals J minus 14 to account for that 14-year difference between the two. The 10-year thing is always the trickier one to do with a question like this. So basically, we stick with, well, one equation or the other. We'll use this one. And we have to add 10 to each of them and then account for this new relationship described in the question. So Jack in 10 years, that's J plus 10, Jack will be twice as old as Bill. Okay, so it's going to be twice something. And we already know that right now Bill is J minus 14. So twice as old as Bill, J minus 14. And we also have to add that 10 years in there. So we can solve a little bit here. So J plus 10, we'll leave that alone. This is 2 times J minus 4. J plus 10 equals 2J minus 8. Subtract a J from both sides, add an 8 to both sides. So we get J equals 18. Of course, that's not one of the answer choices because the question is actually asking how old will Jack be in 5 years? We need to add 5. So J plus 5 equals 18 plus 5, which equals 23. Answer choice D. Okay. Number 154 on page 174. We have 5 hours and 30 minutes, 5 hours and 20 minutes. Forgive my smaller abbreviations. 4 hours and 48 minutes. 3 hours and 12 minutes, and then 2 hours and 40 minutes. Okay, so an empty pool being filled with water at a constant rate takes 8 hours to fill 3/5 of its capacity. How much more time will it take to finish filling the pool? So, 3/5 of the capacity, let's say x is the full capacity, or the full time, sorry. Because if it's 3/5 of the full capacity, it's also 3/5 of the full time because it's filling it at a constant rate. So 3/5 of that full time equals 8. So we multiply both sides times 5. 3x equals 40. So x equals 40/3. So that's the full time that it would take to fill the pool. That's the same thing as 13 1/3, and that's total hours. Of course, that's not any of the answer choices because that's not what the question is asking. It's asking how much more time will it take to finish filling the pool. So we need to subtract the time it's taken so far. So 13 1/3 hours minus the 8 hours it's taken already equals 5 1/3 hours. A third of an hour is 20 minutes, so I suppose this might be a little trap here if you if you're just thinking about 3, in the denominator of the fraction and you choose 5 hours and 30 minutes. But answer choice B, third of an hour, hours are 60 minutes, 20 minutes is 1/3. Yes. 174, second column. Question number 155. So we have 9/4, 3/2, 4/3, 2/3, and 1/2. A positive number x is multiplied by 2, and this product is then divided by 3. If the positive square root of the result of these two operations equals x, what is the value of x? So we have x, and we multiply it times 2, and then we divide it by 3, and we take the positive square root of that whole thing, and that equals x. And of course, 2 divided by 3, 2 divided by, come on, there we go. 2 divided by 3 is the same thing as 2/3. And so this is really the square root of 2/3 x. Square root of 2/3 x equals x. The best next step, of course, is to get rid of the radical sign, so we square both sides. That leaves us with 2/3 x over here and x squared over here. And then we actually also want to get rid of the fraction, so we multiply both sides times 3. So we get 2x equals 3x squared, and we can get everything over on one side of the equation. That's 3x squared minus 2x equals 0. Once you get a quadratic equation set to 0, you have an easier time because then you can figure out what the two factors are, one of which needs to be equal to 0 for the expression to equal 0. We can factor an x out of this equation. So this is the same thing as x times the quantity 3x minus 2 equals 0. And so even though it's not the same thing as two binomial expressions multiplied times each other, one of these two things still needs to equal 0. In this case then, x itself equals 0, or we have the expression 3x minus 2 equals 0. Add 2 to both sides, we get 3x equals 2, x equals 2/3. So there we have it, x equals 0 or 2/3. But we do find out from the prompt, it says that positive number x is divided, multiplied, and then square rooted. So that rules out the possibility of 0 being a value for x. So we are left with 2/3. Answer choice D. (174), number 156. 1.25%, 3.75%, 6.25%, 6.67%, and 11.7%. Okay. A tank contains 10,000 gallons of a solution that is 5% sodium chloride by volume. If 2,500 gallons, that's 2,500 gallons, of water evaporate from the tank, the remaining solution will be approximately what percent sodium chloride? So we're given this in the form of a ratio, sodium chloride over the total solution, which is water, and we know that it's a 10,000 gallon tank. That's pretty big. Probably bigger than my home. We know that it's 5% sodium chloride. 10% of 10,000 is 1,000, so 5% would be half of that, which is 500. So we know that the current ratio is 500, 500, I guess, gallons. 500 gallons of sodium chloride out of 10,000 gallons of water. So if 2,500 gallons of water evaporate from the tank, the remaining solution will be approximately what percent? So the amount of sodium chloride, salt, table salt, the amount of salt stays the same. So it's still 500, but we need to lose 2,500 gallons of the water. So 10,000 minus 2,500 equals 7,500. We can simplify the fraction. That equals 1/15. And if you can do 1/15 in your head, more power to you. I'm not that smart, so I would have to do the long division out the hard way. So it's going to go in 6 times. And we can see already that it's going to be repeating decimal. We add another 1. It's going to be that again. So 0.6 or 0.06. And that expressed as a percent, we move the decimal point over 2. So it's actually going to be 6.6 repeating percent. Closest one to that, rounded then, is choice D, 6 2/3%. Number 157, page 174. So we have 10,100, 20,200, 22,650, 40,200, 45,150. So for any positive integer n, the sum of the first n positive integers equals n times the quantity n plus 1 all over 2. What is the sum of all the even integers between 99 and 301? 99 to 301. We need the evens. And then we have this formula for the sum of the n integers in a set. We have n plus 1 divided by 2. Right, so of course this one has a couple tricks to it. One is that we have the application of a formula, which ought to be straightforward, but we only want the even numbers from 99 to 301. So, and we're only given some formulas. So we would actually need to figure out the sum of the evens up to 301 minus the sum of the evens up to 99, and that will equal the sum of the evens from 99 to 301. So I'll just write that out. We need the sum of evens to 301 minus the sum of the evens to 99. And that equals the thing that we're after here. Right. So keep in mind then that there are actually only one, so we're actually going up to the last even number before 301 is 300. The last even number before 99 is 98. So we actually are only counting up to there. And from the numbers from 1 to 300, there are actually only 150 even numbers. So we actually only have a set of 150 numbers. So that's 150 times, so 150 is our n. Add 1 to that, times, or divided by 2. But then we have to multiply times 2 to get us back up to the fact that we're going, not adding the sum up to 150, but the sum up to 300. We subtract from that our same little set here. Now again, there are actually only 49 numbers, 49 even numbers from 1 to 98. I just divided each of these by 2, by the way, to get these. That's a division sign, divided by 2. This guy also, divided by 2. So we divide that by 2 to get the 49 numbers here, because 49 and 49 is 98. Our n plus 1 is going to be 50. Divide by 2 because that's what the formula says, but the whole thing also needs to be times 2 because we're doing the even numbers up to 98, not all the numbers up to 49. So then we solve from here. Obviously the 2's cancel each other out. So then we have 150 times 151 minus 49 times 50. And what we want to do here is try and get these numbers to look more alike. You could just flat out multiply them out, but I'm lazy. 150 is the same as 3 times 50. So now we have a 50 in both sections. So we can kind of multiply this out again. This is the same thing as 50 times 3 times 151 minus 49. We'll carry this over up here, rewrite it so we don't lose track. Just pretend I didn't put that minus there yet. So 50 times 453 minus 49. Same thing as 50 times 404. And when you multiply it out, 50 times 404, you can actually kind of already see that that's the same thing as 50 times 400 plus 50 times 4. That's the easy way of doing some of this more compound math. You can also just do the long multiplication, but 50 times 400 is going to give us the 20,000. 50 times 4 gives us 200. That is answer choice B. The answer in the OG, the explanation in the OG gives symbols and formulas and stuff like that. I chose not to use that because not everybody is as familiar with those, and these explanations are meant. These Grockit explanations are meant for people who need explanations. If you were happy with the ones in the book, you can just go with that, actually, if you want. Anyway, so just know that there's an alternative in the official guide. Comes out to the same thing. Anyway, last one then on page 174. Forget that little mark, that was an accident. Number 158. Okay, so we have W over M, W over W plus M, W plus 3 over M plus 2, W plus 3 over W plus M plus 3, and W plus 3 over W plus M plus 5. Okay. So a committee is composed of W women and M men. If 3 women and 2 men are added to the committee, and if one person is selected at random from the enlarged committee, then the probability that a woman is selected can be represented by which of these following answer choices. So remember, when we're dealing with probability, that equals the desired outcomes out of the total outcomes, where desired is just the word for what you're trying to figure out, not necessarily what you want to happen in real life. So you could have a probability of being punched in the face, and you would still be figuring out that desired outcome out of the total. I don't know why I keep mentioning that. I guess I just figured that any bit of clarity might help people who aren't used to dealing with probability. So we have W women and M men. So before we add anybody, we can figure out what the probability is of adding women. And we don't actually need to do that for this problem, but I just kind of want to illustrate how this works. So we have W women. The total group is the women plus the men. So the probability before they add anybody is just the number W out of the total group, which is the men plus the women. But we have to figure out what the probability is with the enlarged group. We've added 3 women. So now it is going to be a W plus 3 in the numerator. And then the total group is W plus M plus the 3 more women they added plus the 2 more men that they added. We can simplify that to W plus 3 over W plus M, that's a plus 5, which is answer choice E. That looks a little bit crazy. Anyway, answer choice E for number 158. On to the next page. We are on page 175, question number 159. How many? Oh, well, right. I'm just going to write out the numbers. 2, 3, 4, 5. How many prime numbers between 1 and 100 are factors of 7,150? So this is not asking us to find all of the factors, just find how many prime numbers, which means how many individual prime numbers, unique prime numbers, are factors of 7,150. So we basically just do the prime factorization, 7,150. You can pick any 2 numbers you want. It helps to be able to tell at a glance whether a number is divisible by 10, whether it's divisible by 3. you can tell if it's divisible by 3 if the sum of the digits adds up to a number divisible by 3. In this case, 7 plus 1 is 8, plus 5 is 13, so it's not divisible by 3. It is, however, divisible by 10 because it ends in a 0. We could have also divided it by 5, but in general with prime factorization, the larger the initial numbers that you can factor out, or the closer the two numbers are to the center, like the factors of 10, if you could factor out 2 and 5, rather than 1 and 10. Okay, that was a terrible example. Anyway, if you keep factoring out like 2, 2, 2, 2, 2, your tree is going to get really long, I guess is the point I was trying to make. But, magic of the internet, I have as much space as I want. Anyway, this is equal to 10 times 715. 10 itself has the prime factors 2 and 5. 715, well, it's divisible by 5 at least, so we divide by 5. 5 times, let's see, that equals 143. 143 is ugly, but it turns out to be divisible by 11, and it is 11 times 13. So, these are the prime factors, but we don't count 5 twice. Because we care about how many numbers between 1 and 100 are factors of 7,150. 5 is only one number, even if it gets used more than one time. So we have 1, 2, 3, 4 factors, 4 prime factors less than 100 in 7,150. This guy here is the trap. This is how many non-unique prime factors it has. Okay. Onward to page 175, number 160. 25 pi, 38 pi, 55 pi, 57 pi, and 64 pi. The figure above shows a circular flower bed with its center at O, surrounded by a circular path that is 3 feet wide. What is the area of the path in square feet? So now you get to see me draw ugly circles. I know that's why you are all Grockit members. Not bad. Okay, so we have O. This distance is 8. We also find out that this distance is 3 from the prompt, which makes our life about 23 billion times easier. So this whole thing is a circular flower bed, the inner part is a circular flower bed. The outer circle, this distance here is the path. So to figure out the area of the path, we need figure out the area of the whole circle minus the area of the bed. That will equal the area of the path. And luckily, we have the numbers that we need to figure that out. Remember, so this is a formula that you should have tattooed. Well, actually, it might be considered cheating to have this tattooed on your arm or something. But the area of a circle is pi times the radius squared. If you don't have this tattooed on your arm, you should have it burned into your memory as a very, 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 very valuable formula for the GMAT. So, we're just going to be doing pi times the radius squared minus a different radius. Pi times the radius squared equals yet some third thing. The area of the whole circle has a radius of not only the 8 for the flower bed, but also the 3 for the path. So, the area of the whole circle is going to be pi times 11, 8 plus 3 squared, minus the area of the bed, which is going to be pi times just the radius of the flower bed, which is 8 squared equals path. So 11 squared equals 121, so we have 121 pi minus 64 pi, because 8 times 8 is 64, equals the path. 121 minus 64 equals 57 pi for our path's area. Answer choice D. Okay. Last one in the first column on 175. Number 161. So we have 22, 23, 24, 25, and 26. The positive integer n is divisible by 25. If the square root of n is greater than 25, which of the following could be the value of n divided by 25, or n over 25? So let's just go with what it gives us. We get the square root of n is greater than 25. That is great to know, and we're trying to figure out what n over 25 is. That shouldn't be too bad, because basically we need to solve for n and then divide by 25. So in order to solve for n, we would want to square both sides. So we would have n is greater than 25 squared. And then we want to figure out what n divided by 25 is, so we could divide both sides by 25. So n divided by 25 is greater than 25 squared over 25. For those of you following along here, 25 squared equals 25 times 25. So n over 25 is greater than 25 times 25 divided by 25. Situations like this, we can cancel that out. N over 25 is greater than 25. The only answer choice that is greater than 25 is answer choice E, which is 26. Sometimes they are not as hard as they look like they might be. All right, on to number 162 on page 175. 15, 12, 9, 6, and 4. So a fruit salad mixture consists of apples, peaches, and grapes in the ratio of 6 to 5 to 2, respectively, by weight. If 39 pounds of the mixture is prepared, Sorry, I was just thinking 39 pounds. I wonder if they would say 39 pounds of the mixture are prepared. Anyway, this isn't the sentence correction section. If 39 pounds of the mixture is prepared, the mixture includes how many more pounds of apples than grapes? So, whenever you see a ratio like this, 6 to 5 to 2, one of the things you should be saying in your head is, what's the total number out of? 6 plus 5 plus 2 means the whole thing is out of 13. So, respectively then, the ratio of the individuals to the whole, 6 thirteenths are apples, 5 thirteenths are peaches, and 2 thirteenths are grapes. So we need to find, so if 39 pounds of the mixture is prepared, 39 is a multiple of 13. In fact, it's 13 times 3. So to figure out how many pounds for real are actually in the mixture, we just multiply the whole ratio times 3. There are, in fact, then 18 pounds of apples, 15 pounds of peaches, and 6 pounds of grapes. And we are asked how many more pounds of apples than grapes. So that's the apples poundage minus the grapes poundage equals 12 more pounds of apples than of grapes. This was apples, peaches, and grapes there. Answer choice B. Okay. 175, number 163. We have 1 over r plus 2, 1 over 2r plus 2, 1 over 3r plus 2, 1 over r plus 3, and 1 over 2r plus 3. This year, Henry will save a certain amount of his income, and he will spend the rest. Next year, Henry will have no income, But for each dollar that he saves this year, he will have 1 plus R dollars available to spend. In terms of R, what fraction of his income should Henry save this year so that next year the amount he has available to spend will be equal to half the amount that he spends this year? Wow. You get a long one like this with all sorts of stuff. It's in your best interest to start creating variables for things because they're giving you all these relationships between things. I mean, by all means, read through it first so you get an idea of what's going on. But so let's just say that S is going to be the amount that he saves this year. Because he's not saving anything next year. And let's say that I, let's use a capital I, just because the lowercase I could end up looking like a 1. His I will be his income this year. And the amount he's going to spend this year, it will be I, his total income, minus the amount he saves. And what the question is actually asking for is what fraction of his income should he save this year? So we're ultimately trying to figure out what the fraction is of savings this year over his income this year. This is what we're solving for as S over I. Okay. So we also know that, so for, let's see, where was I? Oh, right. For each dollar he saves this year, he will have 1 plus R dollars available to spend next year. So every dollar he saves this year, he will have 1 plus R. So 1 plus R times the dollars he saves this year equals the amount that he has to spend next year. And we want that to equal half the amount that he spends this year. And we figured out what that is. So we want that to equal his spending this year divided by 2. So then we start cross-multiplying and stuff and junk. So first let's get rid of the fraction, the denominator on the right-hand side. We'll multiply both sides times 2. So we have 2 times an S times 1 plus R. I should probably write that over here. That is the same thing as S plus RS. So he'll have 2S plus 2RS over here. And then we have 1 minus S, or excuse me, I minus S over here. Wow, that could get us into trouble. Let's add S to both sides. So we end up with 3S plus 2RS equals I. And then we can factor an S out of this equation. So, or kind of factor it out of this expression. So that's S times 3 plus 2R equals I. And remember, we're trying to solve for S divided by I. So we can basically just divide both sides by I, or yeah, we need to divide both sides by I and then divide both sides by 3 plus 2R to get these things isolated. So let's do we'll divide both sides by I first. We get, we're going to go over to the next column here. Dividing both sides by I, we get S times 2R plus 3. It's the same thing as 3 plus 2R in the other order. We divide that by I, and then this over here, I divided by I gave us 1. And now we want to divide both sides by the 2R plus 3 because we're trying to reduce it to S over I. So we get S over I equals 1 over 2R plus 3, which is answer choice E. So as scary as this one is, being comfortable with assigning variables to things and expressing their relationships in terms of algebra is absolutely essential to success on the GMAT. I think this is going to be a good place to stop. It's possible I could do the next one in enough time, but we always have to make sure we have enough time for whatever the next broadcast is. So I think I'll just stop there. You've been watching the Grockit.com OGTV broadcast. We were going through the GMAT edition, 12th edition of the official guide to the test. My name's Jim Jacobson. I have been your voice over the internet today. And so next time we will pick up with question number 164 on page 175. Hope to see you then.